Hey, all, thought you might enjoy that time lapse, a little thunderstorm activity out to our southeast, and that's along that sea breeze working its way up northward. We are under a synoptic scale southerly pattern here in Texas, and let's take a look outside and see what we got at this moment. It's dark. No, hang on a second. Just got to move the window up from the bottom left. There we go. That little storm we had to the southeast there, it has fallen apart, and you can see it's dominated by mostly anvil, so it's predominantly a downdraft. And if you look around on this cloud for very hard towers, you can see there's very few of them. Everything is fuzzy. There's just a few remnant updrafts here and there, and just otherwise. This is a decaying storm, maybe a little bit of something on that tail end. Let me see if I can show that to you here real quick. Yeah, that's going to be right here. Yeah, you see that right there. That's probably along the western periphery of that storm, and that could be a new tower trying to form there, but it's starting to get kind of late in the diurnal cycle. And take a look at the tropics. Well, I've got this chart up, so we'll take a look at that. Not much going on in the Atlantic right now. 5-day forecast also showing to be pretty quiet. And we'll look at the East Pacific. Normally that doesn't bother us too much, but we've got Fernanda out there, and that's a Cat 1 storm up to 80 miles an hour, sustained winds. Pressure 990, that's kind of high. And as expected, that's tracking west-northwest. Okay, there was a little change I made in the stream there, and some of you on mobile devices may be happy about this. I went ahead and set this back under the stream output. I brought this from medium to fast. So what that means is that the creation of this MP4 X264 file that you're watching, there's going to be less work done on your end to decode that. So the stream may look a tiny bit worse, but people should have less problems with the streaming, I think. So I know David Moore sent me an email about that. So hopefully this helps out a little bit. And I saw one of you got a smart TV there. Yep, Tom J. using the smart TV. Good deal there. Justin Pulliam is here, and Burl H, ADW, Lloyd McCarter in Little Rock. Ron reminding us to click the like button, and I appreciate that. Kevin McKinney saying hello. Tom J. noting some high-based monsoon storms around the Las Cruces area, and that produces wind in that area. Alexi there in Central Texas also joining us. Ryan there in rainy, stormy South Florida, and Carl Berghoff says he finally got his internet back up. Okay, so the synoptic scale picture showing the Bermuda High, the ridge, the big ridge coming from the east, working its way into Texas and putting us under southerly flow. You can see kind of a disrupted appearance here to the wind flow, so maybe we haven't completely eliminated the outflow boundaries from a few days ago. But down to the south you can see that sea breeze from about, let's see, Lufkin to about Centerville, out to Austin and to San Antonio. Let's see if we can see that on the satellite imagery. I've got the sector a little bit far north, but we can kind of see it down here in the lower left. A little bit of that sea breeze activity. And what we have up to the north, that's the frontal thunderstorms along the short waves moving southeast out of Canada. These are basically along the cold front, kind of extending west to east like that. The boundaries tend to push southward, and they slow down and stall anywhere from Missouri, I-70 corridor, down to I-30. So it looks like probably a bit of a, well, I wouldn't say a rainy pattern, but chances of rain. Arkansas, Missouri, Tennessee, probably hovering around 20 to 40% there. A lot of storms there in MCS, looks like, in Kansas there, from south of Kansas City to just north of Wichita. And so that may develop into a little bit of a short-lived MCS tonight. And about that sea breeze, well, first I wanted to look at dust out in the Atlantic. Well, we don't have any hurricanes to look at, but this is kind of, playing around with the enhanced capabilities of these polar orbiters. And usually what I'll do is I'll go to this aerosol optical depth, and that'll help us find anything from dust to smoke. And that's what we call lithometeors. So those are just basically chemical substances in the atmosphere that are solids. And looks like we have a bit of a plume coming off the African coast, and maybe kind of a localized hotspot there north of Brazil. And let's see what we got out in the Gulf. Not much. Looks like maybe a little dust in the central Caribbean, but none of those red plumes that we saw last year coming up into Texas. And when we had one of those plumes up here, I think if you go back again to July 5th or 6th last year, we were looking at visibilities down to about 3 to 4 miles, and the sky was very yellowish. And there's some of that smoke there up in Alberta, and I'll put up the coastlines and borders. And yeah, that's definitely northern Alberta right there around Fort McMurray. Okay, in terms of sea breeze, we'll zoom in on Texas, and you can see that boundary getting started right there, working its way inland. And that's because of the intense heating inland, contrasting with the relatively cool conditions off the coast there. So we get kind of a circulation like that from south to north, from offshore to inland, and we get kind of a reverse pattern during the nighttime. We get a land breeze, not quite as noticeable, and no precip with that. Let me check out a couple of the other images. Yeah, that's earlier in the day, and there we go. So these are what eventually worked its way up to our area, and that's what you saw in the opening clip. Pretty amazing how you can see the Dallas-Fort Worth Metroplex there. If we take away the roads and everything, it's pretty spectacular. You can see that there from space, and you can even see the shopping plazas. It's kind of hard to, it's kind of fuzzy, but they look like dots every mile. And that's the strip malls and commercial areas at the major intersections there in Plano. So we do have a couple of thunderstorms out in the New England area, and actually just off the New York coast. Let me scroll backwards here. SPC had I think that's a severe thunderstorm watch there for southeastern Pennsylvania. And then we got this marginal area from the Ohio Valley out to Kansas, and that's along that front. You can see how clear it is there in the North Plains. We've brought some much drier air southward. And there's a look at the chart, very obvious what's going on here. Lots of northerly flow in Iowa, Nebraska, Illinois. So we can basically take that and just draw out the boundaries. Something like that, and this station here, that's probably on the back side, getting a little outflow from the south. And then moving south into Texas, looks like our high dew points have kind of moderated a little bit. We've got lots of 60s along and west of I-35, and you have to go well out into deep East Texas to find the mid-70s, but there they are. And that's all it took to get those storms going and persisting through the afternoon. Up in the northeast, yeah, we did have some thunderstorms in the New York City area. Try to get this centered here. And you can see the very cool temperatures up in upstate New York. 59 there at Boston, just amazing. And south of that, we've got 78 there at JFK. So I would be inclined to put the boundary something like this. Maybe an older bound. Well, this is probably the newest boundary here, a little bit of outflow. Yeah, that's probably the front right there. So kind of set up something like that right there. And you can see how high the dew points are in Virginia and the Delmarva area and New Jersey. Lots of low to mid 70s dew points. So yeah, 76 there at this one station here. Southeast of DC, that's some very muggy air. All right, looking at the upper level pattern. Let's see, what do we got here? Got that deep low off the British Columbia coast, and we've been watching that for a while. And we're expecting a bit of a Rex block to get developed with this ridging in Alaska and building northward. And we should see a closed high north of a closed low, and that's that Rex block that we were talking about. And that keeps things pretty stable downstream. So we're just going to see this jet stream along the northern tier states pretty much remaining in place. And there's a close-up look at what's happening in the southern U.S. And we can see the upper level ridge pretty much traced out like that right there. So you go north of that blue area, you've got westerlies. Then you go south of that blue line, and you've got easterlies, and these are kind of like tropical easterlies. That's kind of like the deep flow that you find in the trade wind belt. So usually when we see that here in Texas, we get kind of an active sea breeze pattern, and showers rolling in every day from the Gulf of Mexico. 250 millibar chart, the 200 millibar chart, pretty clearly showing that high pressure area. Looks like that's centered over Missouri. So I would expect to find a lot of very warm weather in places like St. Louis and Paducah and Louisville. And yeah, well, actually not too hot. Looks like it's been broken up by a lot of thunderstorm activity. But you go just south of there, yeah, upper 80s. I guess it's not too bad underneath this ridge, but typically underneath high pressure, aloft, we expect to find some very warm conditions, especially when that's over the desert southwest in Texas. 700 millibar, that's kind of one of the charts we use for capping. And what I'm looking for here is the highest values, and I see maybe 10s close to the Rocky Mountains. And then we find our 8s kind of pretty much all over the place. So this tells me a little bit of weak capping underneath this area where we have 9s. And then on either side of that, the cap just a little bit weaker on either side there. So this is kind of a consequence of the subsidence underneath that upper high. And one way we can see the subsidence is to look at the water vapor imagery. And well, we've got quite a bit of moisture near the surface, but aloft. And we got to keep in mind that the satellite here, this is sensitive. The water vapor is sensitive mostly to moisture above 10,000 feet, and we do see kind of a darker shade through this area right here. So that's some of the subsidence underneath the upper level high there, but storms have managed to get going anyway there. It's probably helped out by the corn belt there, all the irrigation there helping to push the dew points up. And then you can see the much drier air sweeping in from the north across Minnesota. Okay, that brings us to our frontal analysis, and that looks pretty close to what we had on the surface chart. Boundary from about New York City to Cleveland, and then south westward towards the St. Louis area. So north of that you can see the thickness lines there, a little bit of packing, but south of that nothing. So very little temperature advection taking place in this region. Very few temperature gradients. Up in the Pacific Northwest, different story. There's the polar air mass right there lurking in the Gulf of Alaska, contrasting very sharply with this desert air right here. I do this a lot. I get the colors backwards. Okay, let's try using blue for cold air. Okay, so there we go. Cold air in the Gulf of Alaska and warm air there in Arizona. So in between you can see the thermal gradient. And keep in mind that the red lines here, these are thickness, and you can think of them as average temperature between the surface and about 18,000 feet. So this is better than just looking at one level at the surface or at 850. This lets you look at the entire air mass through a considerable depth, and that can really help you kind of weed out things like outflow that might be kind of covering up and masking where the true front is. So what we see here is front extending from southern Alberta, from Calgary, from Cardston, I guess Lethbridge, down to Oregon. Wow, I never realized how close Oregon is to Alberta. It's probably a day's drive right there. And then a warm front southwest like that. So a very clearly delineated frontal boundary. So why don't we see if we can find that on the surface chart. Patterns out there in the northern Rockies, they tend to be kind of masked, so this will give us a chance to try to find out what the surface chart shows. And we kind of drew things out kind of like this, and then our warm front went like that. So is that what we have right now? Well, I can definitely see downslope there in Montana, 93, 95 north of Kalispell up to Browning. And you can see the lower dew points there, lots of 30s in this area here. And that's due to the parcels sinking, or actually not sinking, but crossing the mountains and condensing, producing clouds, and then they emerge on the other side with less moisture. So it looks like our warm front, refining this based on the surface chart, I would probably go with something like this here. Then maybe bring that down to the Rapid City area, something like that. So from about Calgary to northwest Montana, or northeast Montana, then down to Rapid City. So how does that compare here? Yeah, that's that would be supported pretty well by the data. And then the other part of the front right there in northern Idaho, where's that at? Let's see here. I can see the northerly flow in northern Oregon, even though it's very warm in here. But based on the wind shift, I'd be inclined to put a front like that from south of, let's see, I'm trying to remember the name of the cities. I used to have a friend that lived here, and I can't even remember. Well, she moved. But the front extending from just south of there to about Medford. Now, one little tool you can use in your array here is theta. And that basically reduces all the temperatures down to sea level. Let's see what the theta analysis looks like. And this is different from theta E because we don't consider moisture. And this is also potential temperature. Well, it's excessively smooth, so that's kind of a problem. We can reduce the smoothing here in digital atmosphere. Let me do that and just see what it shows. If I'm dealing with something like potential temperature, sometimes I like removing the smoothing completely, almost completely. Now let's see what that field looks like. So it's a little bit noisy there, but now you can start to see the features come out. So sometimes too much smoothing is too much. So dial that down if you have a tool like Digital Atmosphere. So you can see from northwest Montana, pretty much where we had that wind shift. And then you can also see the boundary on the other side. And we could probably be justified in putting the warm front like this. I mean, technically that's correct, because the front is defined by temperature gradients, and the warm front's going to be on the south side, the equatorward side of a thermal gradient. So let's check that out. Let's see what the data shows. So yeah, we could probably do that. It's a little strange seeing 90s north of the front, mid-90s like that, but it is supported by the potential temperature data. Now let me take you over to one other way to get potential temperature if you don't use digital atmosphere. This is another way to do it. Go to SPC. And we're going to go to the Pacific Northwest. And they do have a potential temperature selection here. So that's going to be under theta here. See, under surface, and then mixing ratio theta. So this is going to give you kind of a combination of temperature and moisture, but what we're looking at is the red. That's your theta field. And then the blue is moisture, mixing ratio. It's not very important right now, but you can see the red lines. There's that same packing right there, so you can draw that front like that. So that's much easier than just using raw data like that and trying to guess where it is between these two stations. So use those techniques when you're looking at storms, not only in the Pacific Northwest, but coming out of the Rockies, like Colorado, New Mexico, the Four Corners. That'll give you a jump on watching systems coming out of the mountains and approaching the plains. All right, let's see here. Let's go to the rest of the chart sequence. I guess we'll take a look at the upper area analysis. We haven't looked much at the shortwave activity. But there's where the shortwaves are right now. The long waves, those are basically just where we have the black lines, where those are kind of like pointing northward. Those are the large-scale ridges. So that's a ridge right there. Then we have a kind of a major trough through here. And then embedded in that are the short waves, and those are very small-scale features. So that would be like this, and maybe another short wave in here. So they're basically mesoscale features. And when you're dealing with data like this, you see how far apart those stations are? Imagine that this was surface data, like in Texas here, and you were trying to find, say, a mesolow or a dry line in between all these stations, that would be very hard there. You would, you could have a dry line maybe over here or over here. So there's a lot of ambiguity here. And it's the same way with upper level systems. This data is just barely good enough to pick up anything in the mesoscale, which includes shortwaves. So we're very dependent on numerical data, the dynamics charts from the upper air runs, from the GFS and NAM. So it's a tool that you do want to use. And over the continental U.S., that's going to be fairly accurate, so you can use that to kind of track your short waves. But you also got to keep in mind that convection can feed back into the upper air charts with these models here. And we do know that we have convection from Illinois to Kansas, so that's going to kind of distort the upper air patterns. So I would not put too much stock in there being a shortwave like this. That's probably just some feedback from the convection. But up here, up north, where we have a lack of convection, the fields there should be pretty reliable, I think. And then along the Red River, I don't think we've had too much convection there, so that would definitely be a shortwave right through here. So let me check that out on the satellite data. Yep, Red River looks pretty clear there, so no convective feedback going into the upper air fields. So that right there, yeah, that would be a shortwave. However, it's kind of the effects with that shortwave are kind of weak because the assumptions that govern vertical motion with shortwaves, those depend on the upper air flow. So if you have very weak flow like you see here with 10 knot flow, that means your vertical motion is also going to be kind of weak. So what you're basically going to get is maybe a little bit of removal of the cap in North Texas, just a very small amount. And that's kind of what I would deduce from that chart right there. So yeah, well, this is probably a good segue into the soundings. There's a sounding for Fort Worth this morning, and this shows a fairly uncapped pattern. This is that critical cap layer right in there from 850 up to 700, and just a little bit of warm air there, so that's helping to support the convection we have out there right now. However, there is some dry air aloft. Once you get about 5,000–6,000 feet off the ground, quite a bit of dry air. And that, of course, will churn down to the surface as the boundary layer deepens. And then we've got this Cape Robber thing. We call that a Cape Robber because when you're trying to get Cape going, severe weather, you end up with a sliver of Cape here instead of a big, broad area of Cape like this. And there's been a few chase years where these Cape Robbers have been a big problem. So that's just kind of a little example of what that is. So we'll probably head into the forecast, and we'll look at the Midwest since we have storms going on there. And this is along that front. So over the next few hours, the stuff in Ohio and Indiana seems to dissipate, and we end up with a little bit of a MCS in Missouri. Not for long, though. The high-resolution rapid refresh pretty much gets rid of that by 3–4 in the morning. Maybe a little bit of late activity in St. Louis. But it looks like kind of a quiet night there. And the reason for that would be due to the very weak storm relative inflow. See, I can see like one isobar right here, and that's it. Very weak flow. in the southern U.S. So we're not really shoveling much moisture and inflow into those storms. And then a look at Texas, what we're going to have overnight. You can see some activity there in Louisiana. Pretty clear over Texas. Then things shut down. You can see a little bit of activity, maybe about midnight around the Longview area. So if I was forecasting in that area, that might be an indicator for me to go and look at some of the data and maybe see if there's an outflow boundary, or maybe if the sea breeze is surging northward with some high theta E's. So I would call that a signal, not necessarily a solution of what's going to happen. And a little bit of high-based activity in West Texas around dawn, and looks like a pretty quiet night. So what's going to happen over the next week? We'll take a look at the 200 millibar chart. Looks like a lot of ridging. There's the upper level high right there, centered over Tennessee, North Carolina. Some of it also over Texas Panhandle, basically all through this area. So we see a little bit of expansion of that upper level high. So that tells me a little bit of warming, probably a little bit of a slight warming trend. And we're also amplifying this trough here over the northern Rockies. So that would mean probably some warm air downslope and into the northern plains. Saturday, Sunday, flow continues amplifying, and looks like we get a little bit of northwesterly flow in the Midwest right there. You can see a trough working its way southeastward. And then the upper high that we had across the central U.S., you can see that's kind of receded westward into the Rockies. So this is basically the cold front and some cooler air working its way southward. Then we see the high building in around midweek next week. The old trough dissipates, or basically pushes eastward onto the coast. And then we see pretty quiet weather pattern, just high pressure aloft from Missouri all the way to the Four Corners area. And you can see this very deep easterly flow across the south. So depending on what the soundings are like, that's going to be a good pattern for afternoon showers in Texas along that sea breeze and wherever we have a boundary. A little bit of a low pressure in South Texas, so we'll have to keep an eye on that. Let's see where that comes from. I'm going backwards, trying to figure out where that low came from. I think it developed over northern Mexico right around here, so maybe there's a little bit of maybe latent heat release with all those thunderstorms. I know Mexico's been pretty active the past day or two, so maybe that's what's happening. But would that give us a low aloft? That could possibly be from maybe outflow from those storms, I think. Because I'm sitting here thinking an upper level low. That's going to be, if you have a baroclinic system, that's going to be associated with cool air in the lower levels, not necessarily warm air, latent heat. We do see that with hurricanes. I guess if you have enough latent heat, you're going to get inflow into this system at the surface. You're going to have upward vertical motion and then divergence aloft. So that will form a high, not necessarily a low pressure area aloft. So I'm sitting here kind of thinking through the dynamics of what's happening down there. And I'm thinking probably just some thunderstorm activity and causing some feedback into the upper parts of the troposphere. And I think probably the dominant process there just maybe, yeah, probably just some cool air and clouds, and kind of a unsettled pattern in that part of Texas. Then we get to the end of the month. High pressure shifts out to the east, and there we go. Right there in Georgia, Alabama, Tennessee. Looks like warming up for that area. And that breaks up that easterly flow along the Gulf Coast. So it looks like we're going to have a lot of different things to look at for the next few weeks. Usually this time of the year, we've just got a big high parking itself across Texas, very boring weather, but it looks like we've got some active weather here in Texas, probably some showers here and there. Let's see what the models go for. This is the 3-kilometer NAM. And there you can see the cold front, showers breaking up tonight. And then for tomorrow, where are they going to reignite? Looks like that's going to be in Arkansas. So that boundary gradually shifting southward. And then we see a little bit of activity where we have the highest theta E values, and that's going to be Louisiana. And then the day afterwards, Thursday, let's see, Saturday. Boundary now makes it into the Atlanta area, northern Mississippi, Shreveport, Dallas. So good chance for showers there, and it looks like maybe the sea breeze and higher theta E kind of teaming up there in East Texas, and good chance for showers there. So I think we're ready to head in the forecast, and I think I'll use the dew point chart for that. And let me take a quick look at the chat. Big black clouds where Eric Hall is. No rain, just 90 degrees. Mike Estwick checking in there from Denver. David Moore says his mobile is working this evening. Good to hear that. Davis here. Brett Dean under a severe thunderstorm warning. Been hot, 95, 76 dew point there. Ray Woody checking in, and Dave says tornado southwest of Edmonton earlier. Sue M joining us earlier there. And Rebecca Ladd, that's a new name. Welcome to the stream. Hopefully we'll see you tomorrow also. And Justin asks, how do you suppress bad data from stations in digital atmosphere when performing analysis? Well, with digital atmosphere, you've got tools there, like if you've got a bad plot here, like this 92 over 42, if you want to get rid of that, just kind of drag across that, and then you pick this data inspector, and you get a QC control panel, and you can just delete anything that comes up in that box. And then when you replot it, it'll be gone. So that's actually pretty helpful for getting rid of bad data if it's causing problems on university websites, or if you just want to eliminate the effects, you can go into this program and get rid of it. Wow, look how cool it is in northern Mexico, and I think that's probably a good reason for that upper level low. We've got 74 there, northwest of Monterey. So probably a lot of, maybe a little bit of dry air aloft possibly, helping to produce some good outflow, producing cold pools at the surface, and I think that may be what's going on there. St. George, 108 degrees Saturday, 15 and over 100 all week from Eric Hall. His children used to fry a raw egg on the sidewalk for fun. Can't do that in Florida. Joshua Gilbert says 69 cloudy in Wisconsin. Andrew says, does GFS see outflow boundaries? Yeah, I believe they're parameterized to a certain extent. but the GFS is not a true mesoscale model, so I think a lot of the convective processes have to be kind of simulated and not really worked out at the small scales. Weather Production says it was 97 and mostly sunny in Washington, D.C. Wow, very warm weather. And Justin Pulliam says, thanks, Tim, easy enough to do. Okay. All right, so we'll head into that final slide there of the forecast. And we'll be watching this outflow gradually sinking southward. We're looking at dew points here. The purple is 70-degree dew points, so that's very muggy air. 60 is less muggy air, that's 60-degree dew points. And then your yellows are going to be 20s and 30s dew points, so very dry. So just heading very quickly into the weekend, you see the high pressure driving that front in Minnesota right there. The front is way down to the south from Cleveland through Paducah, Little Rock, Oklahoma City, and that high over Minnesota driving that front southward. For Saturday and Sunday, front continues driving southward, and now you see the high pressure in western Illinois. So anywhere along that boundary, especially when you're in this rich purple shade, you're probably going to be running 40 to 70% chances of rain. For Sunday and Monday, we're going to be seeing that boundary kind of stalled out there from North Texas to Georgia. And we see the broad scale flow starting to return from south to north. So that may start lifting that boundary northward. Monday and Tuesday, very deep southerly flow, so yeah, that boundary is going to move northward. This looks like the leading edge of that. So from Little Rock up to central Kansas. Cyclogenesis there in the high plains. Wednesday and Thursday, continued cyclogenesis in Nebraska. Looks like a new high forming in Manitoba with a new boundary coming southward. Wednesday, Thursday, and Friday, that high sinks into Minnesota. Boundary looks like it's from upstate New York to Chicago to Kansas City. So it looks like more rain for the central U.S., afternoon showers. And we see this boundary stall out somewhere from Kentucky to Kansas. But considering that the parameterization of convection in the GFS is not that great, we could actually see the boundary a lot further south or a lot further north. It really depends on what exactly goes on with the convection and how widespread it is. So we really don't know. There's a lot of questions going into the end of next week. But we do know that the broad scale pattern has a southerly flow, and we've basically just seen a front kind of stall out and move back northward. So I would certainly go for above average chances of rain from Nebraska to Kansas, out to Kentucky, Chicago, Wisconsin. And then south of I-40, I'm a little bit less confident in the rain, especially west of I-35. You can see a lot of dry air in that area. And then for the 24th, 25th, 26th, GFS trying to bring in something from the tropics. We've seen it doing this for a while. And then you can see it's got whatever it is moving along the coast. Well, the tropics not too favorable for severe thunderstorm or for hurricane formation right now. But let's take a look at the run here. You can see the deep easterly flow there. Basically the trade winds. And you can see one easterly wave around Saturday. And that moves all the way up to the Bahamas by Sunday and Monday. And then we're probably watching this area for whatever the GFS is trying to develop. So here you can see a easterly wave ridge. So there's some good weather there. And then you can kind of see a flattening right here. This is a easterly wave trough. So there's a ridge here, another ridge here, and there's a trough in between. So very subtle patterns here. So with this, I would expect maybe rain moving into a little bit of rain maybe on Tuesday for Puerto Rico. And basically, as these waves move east to west, they give you alternating days of rain, maybe a couple days of sunshine, and then more rain again. That's what gives you your variability from day to day. Then, as far as that tropical system, it looks like it may be this thing right here on Friday the 21st, moving up to Dominica. And then it closes off, I think, over Cuba. And then we see it pick up right around Miami right there. So, I don't know. We'll wait and see. We just, looking at this, we know that the origin is going to be in the Caribbean, somewhere in this area. So we'll kind of monitor that over the next week or so. And I'm sure Ryan will keep us updated because he is closely watching the tropics there, and that's a big help for the webcast. Okay, one last look at chat, and before I do that, I'm going to update the satellite imagery. See what these storms here in Missouri are doing. Yeah, daylight is fading. You can see those overshooting tops right there. Okay, let's see here. David asks, have you done any video tutorials on digital atmosphere? Yes. Yeah, go into the channel, this channel here, and search for digital atmosphere. And I think it was about a year or two ago I did do a how-to on using digital atmosphere, and there's also a how-to for Mercatus. Ryan says he challenges the GFS, nothing gonna pop. Conditions still unfavorable in the Atlantic, and Ryan watching all the ingredients there. Okay, well, I think that's about all I got for tonight. I appreciate you joining, and hope you have a good Thursday night, and we'll see you tomorrow night. Take care.